Hi guys, welcome to Origis Computer Classes once again. How are you guys? Hope you are doing well, right? So in today's lecture, we will be seeing one more sorting technique. Now this comes under sorting techniques which follow divide and conquer algorithm. Now the first one among them is the merge sort. Okay, another one is quick sort, which we have in today's lecture. We will be seeing merge sort. So merge sort is also, first of all, it is a sorting technique. So what will it do? It will actually accept an array and it will arrange it in ascending order, right? That is what we have seen in case of bubble sort, selection sort, right, and insertion sort. Okay, so those are the sorting techniques which actually follow a time complexity big O of n square, and those doesn't follow any kind of divide and conquer algorithm. Now merge sort and quick sort, both of these sorting techniques came just in order to optimize the time complexity, the number of steps taken in the worst case. So divide and conquer algorithm, how does it follow divide and conquer algorithm? See, first of all, this is an array. So in order to conquer, here the thing conquer means ultimately to arrange the array in ascending order. So that is our final step. Okay, that means first we will be dividing the array into some parts, certain parts, right, and then we will be again merging them, right, we will be again merging them in a sorted manner, getting my point? Now how to divide this array? So first of all, this follows divide and conquer strategy. Divide and conquer strategy. Now in order to divide the array, so from where do you think we should divide the array? First we should divide the array from some midpoint, alright, and we already know, if you have watched my lectures on binary search technique, how to find the mid of the array, right? So if this is my starting point, if index 0 be my starting point, say this is my starting point and this is my ending point, then how do we calculate the mid? Mid is start plus end by 2, right? Or in an optimized form you can also write it like s plus end minus s by 2, right? So this is nothing but just an optimized form, because see, if start and end values are too large, if the size of array is very huge, in that case if I am adding, at some point it may come that the range which we are getting, it may cross the range of data type that we are using. If the array suppose say is integer and the range that we are getting, the total value of start plus end that we are getting, so if that happens, that may cross the range of the integer, okay, which will cause a problem during the runtime. So that is why we are just, this is considering subtraction from the end and then dividing by 2, right? So this is just normal mathematical derivation, so we get this formula another, right? Fine. So ultimately what is our mid here? So 0 plus 5 by 2, so 5 by 2, that is your 2, the mid occurs at 2. So this is our midpoint, right? That means from here, from 0 to mid will be one portion, and from mid plus 1 to till the end will be one portion of the array. So if we divide the array, first of all, so this is our mid plus, this is our point of division. One portion contains from 0 to mid, right? another portion contains from mid plus 1 to e minus end minus 1. Fine. So this portion consists of the values 12, 11, 13, 12, 11, 13, right? And this portion again contains 5, 6 and 7. And these are now two separate arrays again. Once again these are two another separate arrays. So the indexing is like here again 0, 1, 2 and here also again 0, 1, 2, right? So let us consider, I mean every time we divide the array, we will be storing these two portions in an array, in another separate array, right? In order to calculate. So when we will be writing the pseudocode, that time we will be saying. Just now let us understand how the steps will be proceeded. Now it doesn't end here. So first we will be proceeding with the left portion and then again the right portion will be divided. So if I divide the left portion again, so calculate the mid now. So if this is my again start in this array, this is my start, this is my end, right? This is my start, this is my end. Fine. So this will be my mid, this will be my mid. Fine. And if this is my here also, this is my start, this is my end. I am just using this formula. Hope you guys know it already. So end, and this will be my mid, this becomes my mid. Obviously, 0 plus 2 by 2. So of course that is one easy to calculate. 0 plus 2 by 2, that is again what here. So now let us divide again. So from 0 to mid, it will be 1/2. 0 to 2, I mean 0 to 1, it will be again another half, right? So if I divide it like this, we draw it in a proper way. If I divide it like this, so here we get 12 and 11, and this is a single array, that is 13, right? 13. So 12 and 11 and this is 13. And again if I just divide this portion, the right hand side, so here we get 5 and 6 and here we get 7, right? Here in the left portion we get 5 and 6, 5 and 6, here we get 7. So indexing is like 0, 1, 0, 0, 1 and 0, right? So this is how again, so we will be dividing this portion because this is also a 2D array. I mean actually ultimately we will be divided in such a way so it will be all single cells up to that. Okay, so if I divide this again, so what is the mid now? 0 plus 1 by 2, that is 0 is the midpoint only. 0 itself is the midpoint. So this is, if this is my start, if this is my end, so 0 itself is the mid, and this is a single element, so there is no more, nothing to left to be divided. It's just a single element or single array, right? So nothing left to be divided. And if I go by this, so this is my start, this is my end, and this becomes my mid. So the new, again if I divide this portion, it turns out to be again, this is 12, this is 11, here we have 5, and here we have 6, right? So 12, 11, 5, 6 and 7. 0, 1, I mean sorry 0, this is 0, 0, index 0, a single elemented, I mean only array that is containing all single elements. These arrays are now containing all single elements, right? So we have completely divided this long array into this portion. Fine. So this up to this portion, what we have done is we have divided the array. So this is divide. This portion is called divide. So now our turn comes. Now we will be going, we should merge these arrays in such a manner that after merging we get a sorted half, right? After merging we should get a sorted portion, right? So up to this, I hope you have taken, you can take a screenshot, and then from this portion we will be proceeding. I am just raising this because there is no more space here. So we will be seeing the how to conquer, I mean how to merge these arrays finally, right? So ready? Okay. So I am just keep a note of this 12, 11. These are the partitioned array. Finally, so this was our divide, and in hand we are keeping this. There was a 13 also, I guess, and here we had 7 another. So from the array, finally we had single arrays, that is 12, 12 one array, this is one array, wait, 12, 11, and this was from some arrays we have divided from. I hope you have already noted. From there we are actually continuing, and this is 13 from a separate tree, right subtree. Okay, so 12, 11 and 7. So 12, 11 and 13. Okay, and here from again from the left half we had 5, 6, 5, 6, and here from a separate tree we had 7. Fine. 5, 6 and 7, right? Now while merging we need to compare every time. While we are merging we need to compare every time the greater or the shorter. Now we need to start our comparison. Now, so this is, if I see these two elements, this is the left half of the tree so formed and the right half of the tree. Okay, just the left portion I am seeing. This is the right portion of the higher parent, right? So this is 12, this is 11. Now we need to compare. So as you can see, 12 is greater than 11, right? So 11 should come before 12. So we should merge them in such a manner, that 11 should come before 12. Okay, and the newly formed array now is 11 and this is 12, right? First, always every time remember, every time while solving, even while during the division also, originally what our system does when we be implementing the code, actually the left half is solved first and then it comes to the right half, right? So slowly first, so this was our leftmost part, right? This part we have solved. This was, if we see this minor part, this was our left half, this was our right half, right? So this portion has been solved, right? Now coming to a bit bigger picture. Now this portion has been sorted. So this is now our left half, this is our right half, right? Because there is a higher parent. Before I raise this portion, if you have noted it down or have taken a screenshot, we'll observe from the higher parent, from around 3 cells array, I have divided this portion, right? There was originally an array containing 3 elements, 12, 11 and 13. From there I have divided with this partition, right? So 13 is the right half of that array, right? 13 is the right half of that array, and 12, here we have sorted 11, 12 is the left portion. Now we should merge them in such a manner, we should merge these in such a manner that this portion remains sorted. If after merging, this portion should remain sorted. Yes or no? So see, 11 and 12, is 13 greater than the last element of the array? Yes, that is true. So there is no need to make any changes, just simply merge them. Just simply merge them to form a new array, that is 11, 12 and 13. Fine. 11, 11, 12 and 13. 11, 12 and 13. 30. Fine. Right. Now, so this portion has already been sorted. Right. Now, finally, we are going to the right half, this portion. Right. This portion will also be again sorted. So now, 11, 12 and 13. Okay. Compare this with the 5 from this half. Okay. This is a separate tree. This is also having 5 and 6, and then we are going to just, first of all, we are going to solve this for this tree. See, when we have merged this portion, this portion will go to the above part. The function will return, call back its previous function, and then it will be reaching the root. Okay, after reaching the root, it has reached this right portion of the array, right? This right half of the array. So this is a tree. This we are going to solve first. First solve this portion of the tree, and then we will be solving these two together. So see, 5 and 6, they are already, okay, 5 comes before 6, so there no need to make any kind of comparison. So 5, 6, these we are merging, and so 5, 6, fine, and then here we have 7. Okay, so 5, 6, 7, there is nothing to be more, nothing more to be compared, because 7 is already greater than 5 and 6 both, so it will come normally as 5, 6 and 7. 5, 6 and 7. Okay, 5, 6 and 7. Now we will be comparing these two. We are going to compare these two, right? So we should actually merge these two arrays in such a manner that these enter, see, 5, 6 and 7 all are actually less than this 11, 12 and 13, right? So 12, 11, 13, I mean here we have 11, 12 and 13. This portion is already sorted. 5, 6, 7 should come before this array. So after conquering, we should, this should be our array, right? That means while merging the array, we need to keep on comparing, and then we should accordingly merge them. If the element is greater than another element, that should be merged in such a way that the smaller element comes before the greater element, right? So how to do that? See, we have till now, we have just seen the step that we are actually merging the array. First we are dividing, and then this step is called as, because this is a merge sort, we will be calling this step as merging. You can also say this is a conquering step. So this is the conquer. This step is, we will be naming as conquer. Divide, and then this is a conquer, or here it is, you can say merge. That is why the name merge sort. So merging the whole array in a sorted manner actually. So how we are doing it actually? See, whenever there is a left tree and there is a right subtree, okay, so this left portion of the array will be using actually 2 pointers, right? 0, 1, 2 for iteration actually. This will be iterating and comparing. 0, 1, 2, 0, 1, 2. So here, say suppose you are having an I pointer, here we are having a j pointer, and suppose suppose I have not stored here yet anything, right? I have not stored here anything. How will be doing it? See, 0, 1, 2, 3, 4, 5. The new array where we are storing, say suppose a k pointer is working here. Fine. Now, this is a common sense, very common sense. If the elements lying in the left subtree, or I mean the left array, is wherever the eye is pointing, okay, wherever the eye is pointing in the left array, if that is greater than the j, pointer j, wherever pointer j is pointing, that means j should come the element of j should come here first. Yes or no? Because see, we are arranging the array in ascending order, so we should manage to store the smaller elements first in the newly formed array, right? So as small the element is, the smaller the element is, that will come first in the array. So now see, just check from here. If I see, say suppose this is the left array, I am naming it as L, okay, or left. The name of this array is left, and this is right. Fine. How we are actually doing it? See, so that means if left of I, okay, or if I say if right of j is less than the left of I, yeah, that is true. See, right of j, if I say j is presently 5, pointing at 5, right, and I is pointing at 11. So who is smaller? 5 is smaller. So right of j is smaller than left of I. Yes or no? Right of j is smaller than left of I. So who will come in the final A? This is also A. Okay, finally we will be storing in A only in the sorted manner. So A. So right of j should come in the A of k, right? Right of j is smaller. So small as it is small. So 5 has come here. This is actually where I have stored right of j, as because right of j was less than left of I. Yes or no? As because right of j was smaller than left of I, right? Now what we are going to do, as we have already taken an element, this is like a game of carom, right? Like the game of carom, okay? When you drop a coin, okay, somehow you drop opponent's coin in some pocket in the carom board, okay, then the same person again gets the next chance, right? So here, as the right of j was same concept, as right of j has got a chance to already enter into A of k, again j will move to the next index to check if there is any more element in this array that is smaller than left of I, right? So see, if till now, again see left of I is 11 now. Till now left of I is 11, okay, and right of j is 6. So what is happening? See, again right of j is less than left of I. So who will be entering into the array first? 6. So 6, as 6 is smaller than 11 again, so 6, let 6 enter the array. So again right of j has entered the array, right? So right j will check for the next element, as because right of j was lesser than left of I, right? Okay. Similarly again, so again j will be moving to the next to check if there is some more smaller element. So in this case, actually luckily we are getting every time the smaller elements in the right hand side, but every time this is not, in every case this is not going to happen. We will be taking another example where the things will not happen same as I mean every time we will not, it is not going to happen that the smaller element is always present in one side only. Okay, so this is 5, 6 and 7. Now just check if 7 is less than left of I. Left of I is again 11 here. So right of j is 7. So 7 is smaller than 11. So 7 is going to enter first. Right? Oh, sorry, the k is also progressing. K will also progress here slowly, slowly. See, when we stored 5, then k has progressed here and stored 6. And then again, while storing 7, k will come here. Right? K pointer will also be moving. Fine. So 7. Now this is a ending point where actually there is no more element in the right of j, and so now we will be proceeding to store the remaining elements of the left array. So remaining elements in the left array is I. So I will now move continuously to store. First 11 has been stored. First 11 will come here. Then I moves. Then actually 12 comes here. Right? I points here. Then 12 comes, then 13 actually, 13 comes, right? So this is how it will be working. But see here actually the example is quite easy because every time 5, 6 and 7, say suppose there is an array. Acha, another thing, these two things while they got merged, they will also be merged in the same way. So when these got merged, actually there we will considering here an I pointer and here a j pointer. This was only one element, so there was no trouble. See, in this case actually left of I was smaller than the right of j, so left of I first came to the array, right? So if this was my k at that point of time, so left of I 11 first stored, then I progressed, and then 12 came in the next half. So this is how it is progressing, right? So this was a very lame example. Let us take another example. Let us draw. Just I will be solving this portion just in order to understand. Let us take another example that how it is actually working. So now let us consider this example. Say suppose this was some separate array. This we had. And after following the same divide strategy, okay, the things which we have followed for this array, we have followed the same divide strategy for this array, and while conquering, while merging, say suppose this is a condition which we have reached, okay. Just don't think that after from this point we have directly reached here. Here say suppose some divide strategy has occurred, okay. Before reaching this stage, we have actually followed some divide strategy. Some divide strategy is followed. Some divide strategy occurred, and then while conquering we reach this. While conquering, after this following this divide strategy, while conquering we reach this stage. Say suppose we reach this stage finally while merging into a final array. Okay, these are the last 4 steps we are left with. So now how to merge it? In the same fashion that we have done for the previous array. So 0, 1, 2. Now just understand the rule. While merging it into a single array, we will be using the pointers I, j, and here it will be k, right? It will be k. So if I talk about this now, left of I and right of j, so we will be just checking who is lesser than whom, right? So as if I check, right of j is again less than left of I, right? Because left of I presently is 90 and right of j is 20, right? So definitely right of j should get a chance to enter into the error of k, right? Error of k. So right of j enters here. So I am writing here right of j right of j as right of j was lesser than left of I. Left of I. Fine. And see now again, so as because j has got a chance, already j has got a chance, so j should get another chance to check if this array is containing any other value. So j will be progressing, j will be progressing to the next element, k will also be progressing with j, okay, and we will not be progressing I because I has not no elements from left of I, okay, from the left array has entered the array of k. Only j will get a chance and k is progressing in order to keep a track of this array where to enter the next element, right? So j has got a chance to progress. Now again we will be comparing who is lesser. So left of I and right of j. So left of I is 90 and right of j is 106. So left of I in now presently left of I is less than right of j, right? So left of I is less than right of j. So who is going to get a chance? Of course left of I, because smaller the element we will be proceeding that to enter. So if after a while, consequently we will be arranging the array in ascending order. So 90 we should now enter, 90 should now enter in the array. So we have it is left of I, it is now left of I, as because left of I was less than right of j. Fine. Left of I was less than right of j, right? And so I will be now in this case again I will be moving to check if there is any more element that is less than right of j or not, and k will also be progressing with I. Fine, right? So again see if 100 and right of j is presently 106. So 100 and 106, who is lesser? 100 definitely. So left of I is going to get a chance to enter into the array, right? Left of I will enter into the array in the same way. So 100 enters the array and left of I, so I will be progressing to this portion. Again now compare. So left of I and right of j. So 105, 106. Who is lesser? 105 definitely. So 105 enters the array. K has progressed. K will be progressing to the next portion. And so 105. This is my 105. Fine. And now no more elements remaining in left of I. So this is a condition where when there is no more elements, of course if there is nothing left in left, so there is no one remaining to be compared now. So all the remaining elements in the opposite array, see if in the previous case what happened, right of j was completed, right? Right of, there was no more element remaining, and left of the remaining elements are definitely going to enter the array as it is. So 106 to 200, if there were any more elements left, they will be entering the array as it is in the form they are here, right? So from 100 just progress. So 106, presently j is pointing at 106, so let 106 enter into the array. K has progressed, k was actually here presently, and then k will be progressing to index 5, right? And also j will progress to this point, and then 200 also will enter the array. So this is our ascending order array. So this was, say suppose this was our original array, and this is the result which we have got, right? So let us just now consider the pseudocode of this problem. So merge sort, I hope it is clear how we are proceeding the steps, right? So just this is a normal, I mean this just works out of common sense. Of course the person who is having the lesser value, they will be entering the array first in order to arrange the array in ascending order, right? So first of all, while we are proceeding with the pseudocode, what we are actually doing first, okay? So let me keep this array only just to observe. Say suppose a random array I am taking. In order to write the pseudocode 1, 2, 3, 4, 5, 6, and say suppose we have the elements 100, 90, 25, 600, 40, right, and then we have 20, and the name of the array say suppose A. Fine. First task is we are dividing the array. First task is what we are doing, we are dividing the array. Also before that we are just finding out what is the midpoint of the array. So say suppose if from 0 to 5 these are my index values, 0, 1, 2, 3, 4, 5, these are my index values, and if this is my start and this is my end, so 0 plus 5 is 5 divided by 2 is 2. So say suppose I am writing, if I write a function for this, for the division portion, so void merge sort, say suppose I am taking the name of the function void, okay, void merge sort, okay, and it will be accepting the parameters. Definitely it will be accepting the array first, the array it will be accepting, then it will be having a low. See, the data types I am not considering here because I am writing a pseudocode, but when you will be implementing it in the code, you should also mention the data types of the variables you are taking. So say suppose A, then L means, or say suppose start and end, say start and end, fine, right, start and then end, opening brace, right. M is equal to, I am considering a variable, say M, that is my midpoint. So as per this 0 plus 5 by 2, that should be 2 should be our midpoint, right, 2 should be our midpoint. So the formula is simple, that is start plus end minus start by 2 should be our midpoint. Fine. Now M is equal to S plus E minus S by 2. So what we are actually doing, we are actually dividing this entire array into two halves, right, constantly. Fine. So if we are doing such thing, so from 0 to M should be one half of the array, and from 3 to 5 should be another half of my array, right. From 0 to half, this is my one array, 0 to 2, and another half is from 3 to 5, fine, from 0 to 2 and 3 to 5. That means we just what we can do, actually this is nothing but we are actually recursively calling the function again and again. Yes or no? Because we are creating two more arrays, we are actually division means what? We can actually call the same function, this function with these arrays, right? We can actually call the same function. See, here we are accepting A. We will be accepting A only, no problem. But see, if we just modify the starting and ending value, then we can just actually just what to do? We can just modify the size, right? Just this is one half and this is one half. For this one function we will be creating, I mean the function will be calling itself for once, and then again for the right half another time the function. So what can we do? Actually, we can call the same function. Basically we can actually call the same function. So what is it? So we can call merge sort, right? It will be accepting the same array, that is no issue though, no problem in that, and we are calling from 0 to mid, right? From 0 to mid we are calling a portion. So my starting value should be as it is, whatever it was. If it is 0 0, then and if it was something other, so 0. So starting should be as it is, it should remain s. But my end is now, end was previously 5, that was n minus 1. If n was 6, then end was 5. Now in this case my end should be mid only, because mid is pointing at 2, index 2, so mid, just directly mid. From start to mid this one portion is created, right? And again merge sort A for the right portion from C. Another portion is from mid plus 1, from mid plus 1 to the end of the array. Yes or no? Mid plus 1 to the end of the array, right? So end should remain as it is, whatever it was, right? Here the end is as it is index 5. Here the start remains same. Okay, so this is mid, and can I say this is mid plus 1? As simple as that. This portion is mid plus 1, right? So from mid plus 1 to end, right? So actually what is happening, this is calling again. So for this, when this function will be working, say suppose after it has called for mid plus 1 and end, again this will be, it is like a recursive call continuously. So actually what will the system do? Compiler will first continuously call this left portion, and after a certain time when we reach a single element, when the start and mid values both becomes 0, when the start and mid values both becomes 0, after that it will be calling the marks of the right portion, it will be consequently dividing it, right? So say suppose after this is working again. So if I talk about this portion, this small portion 0 1 2, again see, for this what is the mid? 1 is the mid portion. So as per my condition, if I am talking about the left half, okay, I am redrawing it here, the left part, as per the condition for the left half. So array remains as it is, but the range now becomes start. What is my start? Start is as it is 0, okay, and end was 2. So now in the newly formed array, I am again for this, again I am called, if this function is called for this, again if this function is called, from start to mid, another form another array from start to mid, right? So this is again my left half. Again from this first left half will be created, and then it will be proceeding all to the right hand sides, okay, then it will be bringing up the right hand sides. This is how it will be working. So from consequently continuously the left portion will be first created, and then it will be going to the right half, right? So simple. Just the things which we are doing, we are just consequently, it will continuously a recursive call. It is like a recursive call, okay, that's it. And now after, when it even completes the right half, after dividing also the right half continuously, I am considering a function that will be merging my array. Say suppose the name of the function is merge, as because it will be merging the array, and it will be accepting the argument say a, and we should also pass the start of the array, okay, it should also contain the mid of the array and also the end of the array, right? So now we should define the merge function, but before that remember one thing, till I mean what time we will be proceeding, there should be a base condition for the recursion, right? If you are designing a recursive function, if there should be a base condition. So when should this call end? When should this calling process end? Only when this, I mean this calling process should go on till the start, the value of start is less than the value of end. Start should never cross end. If that is happening, the array is already sorted. So this call should happen only until start is less than end. Start is less than end. Okay, this call should happen only if start is less than end. So this continuous recursions will happen, and it will, after these recursions, it will call the merge function finally, right? So I hope this portion is actually doing the division operation. Fine. This portion is actually doing the division operation, divide, and this portion will actually do the work of compare. So just writing now the merge function will do our work, as simple as that, right? So division portion done. This is my merge function. So now let us define the merge function, and that will be the end of our code. And then after that, obviously you are going to define the main function to call this merge sort function, and it will do your job, right? So what is our merge function? So I hope you have copied up to this, or you have taken a screenshot. So let us proceed with the merge function, right? So what were the steps we are following while designing the while merging the array? So say suppose I am taking here void merge. It is accepting the array. It is accepting the starting point, accepting the mid, and accepting the end. Yes or no? Right? So if this is my function, you should obviously mention the data types. I am again and again saying, while writing the practical code, you should mention the data types, the variables, right? Now, so left, if I consider the size, we should consider two arrays, that is left and right. Yes or no? So before taking those arrays, we should consider their size. So say suppose in one, the size of the left array, what should be the size of the left array? If I am numbering the array from 0 to 2, if in the last index of the array is 2, then the size of the array is 3, right? So what should I consider in terms of mid and start? Because it is not going to happen every time that we are going to get a 3 sized array. Okay, it will vary depending upon the size of the entire array. So can I say it is like 2 minus 0 plus 1? 2 minus 0 plus 1, that is the size of the array. So 2 minus 0 is 2 plus 1 3, that is the size of the array. So it's like mid minus start plus 1. Fine. And what is the size of the right array? Size of the right array, it is also 3. But how we are getting it in terms of end and mid? We should get it in terms of end, write it in terms of end and mid. So it is nothing but simply it's like end minus mid. What was our past mid? That should be our, right? So it's like end minus mid. So what is my end value? End is 5 and mid is 2. So end minus 5 minus 2 is 3, and that is our size of array. Yes or no? So n2 we can write it as end minus mid. Fine. End minus mid. So if I consider two arrays, so left should be having a size n1, okay, and right should be having a size n2. Fine. See, this initializing of the array depends upon the code that you, the programming language you are using. If it is Java, it is like left equal to new int n1, okay, left equal to new int n1 and right equal to new int n2. Fine. So depends upon the programming language you are using. So left of n1, right of n1. Now we need to merge the array, right? So we need to iterate until we are proceeding while I less than n1 and also j should be less than n2. Okay, so first let us initialize the pointers here. So I should be 0, j should also be 0, okay, and k should depend upon the starting value of the original array, okay. the starting value wherever the j is pointing. So starting it is not necessary start will always point to the 0. Okay, it depends on where it is. Okay, for say right array starting point is 3. Okay, while merging. Okay, so k should be like starting start. For right I mean for the original array the index is 3, right? So k should be like starting wherever the start is pointing the original array. And but in the if I talk about right array, then this index is 0 again. Okay, right as it is a separate array. Getting my point? Because right is another separate array. So j less than n2, and what were we doing? Simple checking. If left of I is less than right of j, fine. If left of I is less than right of j, then ARR of k or A of k is equal to left of I, right? Opening brace here, then I plus plus, and then k plus plus, right? Fine. So this is the thing which we are doing. So I am just continuing it. I am just erasing this portion. I am continuing it from here, the while loop. See, everything that I am going to write, it will be inside the merge function, right? It will be inside the merge function. So while I less than n1 and j less than n2, see, this is inside the merge function. This is a continuation in the merge function only, okay? In the merge function. So while I less than n1 and j less than n2, opening brace, if left of I is less than right of j, then A of k is equal to left of I plus plus, k plus plus, okay, right? Otherwise, else what you can do? Of course, that means if this is not true, then right of j, I mean we should in fact mention the condition here, because otherwise what will happen, it will also take the equal condition. So if right of j is less than left of I, then A of k is equal to right of j, then j plus plus, k plus plus. Fine. And this is the end of our, no, not yet the merge function has end, but this is the end of our while loop. Okay, merge function is still going on. See, after doing these steps, see, because this is we have just calculated who is lesser than whom, and then A of k has got the elements. Now it is the turn to insert the remaining elements in the array. Fine. So up to here we have just compared the elements and merged the last step that we were doing, right? So this is the step we have done, and then if we proceed, so we will be considering the remaining elements. So if I continue doing it, see, either the left array has remaining elements or the right array has remaining elements. So if left array has remaining elements, we can write a separate while loop. So while I less than n1, A of k is equal to left of I plus plus. Fine. While again, if the right element is not having, right element has remaining elements, right array, okay, right array has remaining elements, then A of k is equal to right of j and then j plus plus. You might be thinking, see, I have written one while loop after another. See, if the first while loop that I have written just now and rest, if that while loop is false, if that while loop has stopped, that means either of the condition, that is I less than n1 is false or j less than n1 is false. Okay, if both would have been true, then that while loop shouldn't have stopped, na? So either I has crossed n1 or j has crossed n1. Now if I has crossed n1, if I has crossed n1, automatically this while loop won't run. Automatically this while loop won't run. So automatically this while loop is going to start, and j less than n1, the remaining elements are going to get inserted in the array. And if j has crossed n1, automatically I is less than n1 and j is not less than, that is why the first while loop has stopped. But now this while loop is going to run, and this while loop is automatically false because j is already greater, sorry, it is n2, j is greater than j less than n2, right? So fine. So if j has crossed n2, then that is, I mean, I is less than n1, so this, the remaining element is in the left array, and it will be coming inside the original array, and finally it is arranged in the ascending order. So this is the end of our merge function, right? So this was all about my merge sort algorithm, and the time complexity is big O of n log n. Okay, big O of n log n in all the three cases, that is the best case, worst case, and the average case, right? Because see, log n is because we are constantly dividing, n is because we are iterating throughout the array while merging, right? While merging we are iterating throughout the entire array, but as because we are dividing and then conquering, so the second n, in case of bubble sort and selection sort, we are having a simple n square, that is n into n. So this second n is turned into log n because we are actually dividing the array, right? And division always has a log n time complexity, as we have seen in case of binary search, right? So this was all about merge sort. Hope you guys have liked this video, right? If you have any kinds of doubt, you may ask it in the comment section. I will make up a separate video where I will be clearing all your doubts. So thank you guys, take care of your family.